All right, here we go. Our objective for today: I can simplify exponential expressions using the division properties of exponents. Read together. 1, 2, 3. I can simplify exponential expressions using the division properties. So we already covered for 2 days multiplication properties. Today we're starting with division. Okay? And what is a major concept that we are still on? Exponential expressions. So the Freyer model, like I said, you should have filled that in by yourself already. Is that correct? Good. So you should have looked something like this. We know that they are numerical variable expressions. They show power greater than 1 with examples, non-examples. So we know that they're expressions only and exponents greater than 1. You can do that by yourself and finish it later. Steps. Write these down. Step 1. Identify the exponential expression as a quotient of powers or power of quotients. So basically for division, we're only covering 2 properties. Identify the exponential expression as a quotient of powers, power of quotients. Identify the exponential expression as a quotient of power of quotients. Identify the exponential expression as a quotient of powers or power of quotients. Identify the exponential expression as a quotient of powers or power of quotients. And notice that the rest is the same. Use the appropriate property to compute and simplify. Yes? Copy that, please. So once again, the 3 steps. Identify the exponential expression as a quotient of power or power of quotient. Simple. Second step, use appropriate properties to compute. And third step is simplify. Say your neighbor the steps, please. All right, so let's see. If you have space, you won't have space. Or let's see. Some of you do have space. If not, turn it over. All right, quotient of powers property. Quotient of powers property. Example Q. All right, write this down. 3 to the 6th power over 3 to the 4th power. Underneath that, x to the 10th power over x to the 7th power. Underneath that, x to the 5th power over y to the 4th power. All right. So once again, I'm going to show you the example. Pay attention so that your noodle can do all the work. You're going to come up with a rule. So focus, please. Pens down, writing utensils down, eyes up here. You'll finish copying right now. Look up, please. Here you go. So we have, let's see, exponential expression divided by another exponential expression. Copy that. As you're copying that, start thinking about the rule and see how you're going to talk it over with your neighbor. Go. All right, good discussion, good discussion. So underneath that, put a little asterisk, a heart, so that we won't forget our rule. So once again, what are we doing here? What operation? Division. So we're going to write when dividing exponential expression okay, so now here goes, I need your help. What was the discussion? Who can, yes? Okay, so then continue from there. Erica said, when dividing exponential expressions of the same base, very good, comma, and then Erica? Subtract the exponent. Do everybody agree with that? Yeah. Straightforward? At the end, 10 cubed. Oh my goodness, what is that? And the reason I gave you the last example right here so that you can see when they don't have the same base, what happens? It stays the same. Everybody see that? All right, so now, really quick, why does it work? Here it goes. Pens down, eyes up here. So I'm going to go first with the first one. The numerator says 3 to the 6. That means 3 times 3 times 3 times 3 times 3 times 3. Do you agree with that so far? Then this one is 3 times 3 times 3 times 3. So far so good, right? So what is 3 divided by 3? 3 divided by 3? 1. Okay. What is 3 divided by 3? Another 1. And another 1. So in the past, the teachers usually said they cancel. Do they really cancel? No. It becomes a 1. Therefore, 1 times 1 times 1 times 1 is 1. What do we have left? 3 times 3, which is 3 to the 2nd. Copy that, please. And once again, this is called factored form. Because when in doubt, factor out. Very good. And do the same to the second one, x to the 10 over x to the 7th, just so that you can have an extra example for yourself. Copy that. So for the second one, you probably did x, 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 x. Nice and straight like mine, right? Oh, I put one extra x. Sorry. Oh, wow. Bam! That's what I'm talking about. And then we got x, 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 x. And we know that all these are 1, 1, 1, 1, 1, 1, 1, and we're left with x to the 3rd. Or all of these together become a giant 1. Do you guys see that? All right, so we got this, right? Let's do some practice. Copy this, please. Example 1, it says simplify for a is 2 to the 9th over 2 to the 7th. At the end, simplify it all the way through with a computation. And then B, we got y over y to the 4th. See what you get. Go. Copy that. All right, good talking. Here we go. Let's see. Are they the same base? Yes. 2. 9 minus 7, that is 2. And I said to do the extra computation. So what is 2 squared? 4. Okay? This one. What do we need to do first before we do anything else? Put the 1. Am I making my point? Some of you keep skipping that step. So this is same base, yes. 1 minus 4 is negative 3. Hands if you got that. Okay, do some more. Here we go. Example 1C and 1D. We're going to do C together. Copy that, please. And it says m to the 5th, n to the 4th over m to the 5th raised to the 2nd power and n. And then we got d, which is 3 to the 5th times 2 to the 4th times 4 to the 3rd over 3 to the 4th times 2 to the 2nd times 4 to the 6th. So let's do C together. Does everybody see the denominator? Does everybody see what I did there? Okay, here we go. So before we do anything else, we need to simplify the denominator. Who sees this? Okay, so let's do that first. This becomes what? M to the 10th and n That's the denominator, and bring down the numerator, which is m to the fifth, n to the fourth. And now let's go one base at a time. Same bases are m, okay? And what is 5 minus 10? Negative 5. Same basis, there it is. And here we need to write our 1, so 4 minus 1 is 3, and we're done. See how that works? Yes. All right, good. Do d by yourself. See what you get for that. Copy that. Okay, here we go. Same base. This is 3 to the first times. Same base is 2. 4 minus 2, that's 2. Times. Same base is 4. 3 minus 6, that's negative 3. If we were to do the extra steps for computation, 2 to the second is 4, is that correct? Yeah. 3 times 4, that's 12, but this one has a negative, we're going to leave it like that, 4 to the negative third, for right now. Everybody got it? Yes? Okay, let's do some more. Kick it up a notch. Example 2a. Copy this. It says simplify. Parentheses 3 times 10 to the 10th divided by 6 times 10 to the 6th. And write answer in scientific notation. Okay, let's do this one together. Here we go. So they give us two expressions, this one and this one. So I write the first one. It says 3 times 10 to the 10th. Are we there? And this one has division, but the only examples that I gave you were in fraction form. Was that correct? So then you do a fraction bar, and then you write the other in the denominator. 6 times 10 to the 6th. Therefore, same basis, that is 10 to the what? 4 times, what is 3 divided by 6? 0.5, so that's 0.5. Are we done? No. For those that didn't see it, 3 over 6 is 1/2, in decimal form is 0.5. Are we there? Okay. So, this is not scientific notation. We have to have one digit on the left side. That means I need to move the decimal to the right. Yesterday we moved it to the left and this increased, right? So when we move it to the right, what happens here? We decrease. So this is 5 times 10 to the third. Yeah. It can't be 0 because 0 is it's just occupying the space. Okay? Got it? Okay, do this next one by yourself. You don't have to copy all the verbatim. Just copy the expressions and do the simplification. Example 2b, we got 3.3 times 10 to the 6th divided by 3 times 10 to the 8th. Simplify that, see what you get. Copy that. Focus, Christopher. B. You're done? Oh, okay. Okay, let's see. Share with the neighbor first before we continue. See what they got for number 2B. Okay, here we go. We got 3.3 times 10 to the 6th over 3 times 10 to the 8. Hands if you set it up to right there. Good? Okay, so from there, same basis. Yes, 10 to the negative 2. So far so good? Times 3.3 divided by 3 is 1.1. Is this in scientific notation? Yes, because there's only one digit on the left of the decimal, so we're done. Hands if you got that by yourself. Okay, not bad. So now let's move forward. Here we go. Write down power of quotient property and write example Q. Two to the third over 3 to the fourth. You're right. Wait a minute, Q. Didn't we just do that? Yes, but check this out. Bam. Parentheses to the fourth power. Pens down, eyes up here. So here goes the rule. That line's kind of crooked, isn't it? Better? Alright, here we go. Writing utensils down, pay attention please. Here we go. Copy that. Okay? Okay, good talking it over. So now, look up please. If I was to write it in factored form, will it work and will I end up with 2 to the 12, 3 to the 16? Yes, right? In factored form. I'm not going to do that, but you can do that by yourself. But let's talk about what's going on here. Notice that what we did previously, like all these didn't have parentheses, and if they did, they didn't have an exponent outside those parentheses, right? And we get to this part, and now we do have an exponent, which means we started with when dividing exponential expressions by the same base, we subtract the exponents. Was that correct? That's what we did first. But now we have when dividing exponential expressions and they are raised to another exponent. So let's write that down. When dividing exponential expressions and they are raised to another exponent. And who's going to help me with the rule? Yeah. I multiply the exponent outside times all the exponents inside. Is that pretty clear? 10Q. 10Q, what's that? Pretty straightforward, yes? Okay, let's do some practice. Let's see how that goes. Here we go. Copy this one. Example 4a, we got parentheses 4 over 7, or 4 sevens, close parentheses, squared. Please tell your neighbor what's the first thing they do. Oh my goodness. Put the 1. And now we distribute the 2 to each of those, and this becomes 4 to the second over 7 to the second. And if I ask you to compute that, what do we get? 16 over 49. Yes? Yeah. For right now, I'll take either or. That's fine. But if I'm asking you to simplify it all the way, make sure you do the computation. Go to the next one. Copy this. Example 4b is 3d to the second e over es. And all that to the fourth power. Do this one together. Once again, what is the first thing we do? Put a 1 on everything that does not have an exponent so that you don't forget to distribute the power, yes? So therefore, that becomes 3 to the 4th, d to the 8 over e to the and f to the 4th. So far so good?
Yes, Mr. T.
Good. This one. Copy that. You're saying, oh, snap, something's going on in the denominator there. We got parentheses 2x cubed over parentheses xy parentheses cubed parentheses squared. Man, there's a lot of parentheses. So now check this out. There's two ways of doing this, but I'm going to do this first by simplifying the inside. So check this out. I'm going to get rid of this parentheses because I don't like parentheses within parentheses. So what is the first thing we do? Put 1s in here, right? So I'm going to do the denominator first. So the 3 distributes into here, so that becomes x cubed y cubed. Is that correct? We bring down the numerator, which is 2 to the first, x to the third, and now we have our exponent of 2. Do the next step, please. See what you get. Just the next step, and then I'll guide you to the end. All right. So I see some of you did this and this. So you got 2 to the second, x to the 6th, over x to the 6th, y to the 6th. Hands if you got up to right there. Okay. Now, at this point, we go to one more step. What is 2 squared? 2 times 2, which is 4. Okay, we got that. But who sees that these are the same base? So what is x to the 6th over x to the 6th? X to the 0, which is 1. Or you can just do this. You see the 1? What's that? Yeah, if you do this right here, I'll accept it. So this is a 1, right? So what is 1 times 4? 4. What is 1 times y to the 6th? Y to the 6th, and we're done. How we doing? Good? All right. One last thing before you leave. Here we go. Hold on. Really quick. If I have 3 to the second over 3 to the 5th, pay attention to this one. This is 3 to the negative 3. Is that correct? Now, if I was to write this in factored form, we know that this is a 1 and this is a 1, right? Now check this out. What is 1 times 1? What is 1 times 1? 1. And 3 times 3 times 3, that's 3 to the third. You're like, what just happened? I thought we said this was this. Yeah, but it's also this. So what am I saying? 3 to the negative 3 is 1 over 3 to the third. So what can we conclude? If I continue doing that with numbers, whenever you have a variable or a number with a negative exponent, you need to write it in the denominator, change it to a positive, and put a 1 on the numerator. Everybody see that? So your home play for tonight is a play sheet. It's up here. Home play is a play sheet. Have a good one, everyone. Enjoy your home play. See you guys tomorrow.